Welcome to Balco's AIA Continuing Education series. Today's AIA course is titled Expansion Joints 101, Introduction to Expansion Joint Technology. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. Balco is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS Group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. Balco manufactures high-performance architectural construction products for the commercial market, which includes a full line of expansion joints, egress systems, fire-stopping products, and much more. You can view our full line of building products at balcousa.com. Balco is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your AIA member number, we will report your course completion to AIA CES records. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by Balco. Any reproduction, distribution, display, or use is prohibited without written permission. In this course, you'll identify the function and purpose of expansion joint openings, understand why these systems are critical to structural performance, and learn how they accommodate movement. You'll also explore common system types, review key building code requirements, and understand best practices for installation and effectiveness. Today's presentation was recorded by Steve Cooper. Steve is Vice President of Promotions and Training for Balco. Steve works directly with architects, specifiers, and distributors on product education and project specifications. With that, let's turn it over to Steve.
So this is a cutaway of a building with an expansion joint in it. So we've lifted off the roof so that you can see that there's an expansion joint running across the roof. It's running up the exterior wall. It runs across the floor, up the walls, and all throughout the structure. It completely separates a building into individual structural units. We tie all these together with expansion joint cover systems, and then we enhance the functionality of these systems by adding water protection and fire protection and thermal and vapor protection and all kinds of things related to keeping the building as fully functional as it would be if it was a solid, complete unit, but it is built with these expansion joints to allow for expansion, contraction, and movement for all kinds of different events. And on the left-hand side, the two pictures there, you can see expansion joint covers in place in a structure. Top left picture is the interior of a building. That's a casino in Las Vegas. It's got two stripes across the floor there where you can see there's an installation. That's an expansion joint, and it's got some tile and some wood flooring recessed down into the expansion joint cover system to kind of hide it. And then on the walls, there's a mirror polished steel member on the expansion joint cover and across the ceiling, and they match that elevator, so they kind of keep that look the same there. And then on the bottom left is an exterior wall joint that runs up to a roof joint. So at the in between where that reddish colored rotunda is, this is Rancho Cucamonga Library in California. There's an elastomeric expansion joint, which is that dark kind of tan colored strip running up the center of the building. And then it runs across the roof. So that's the interior and the exterior of an expansion joint system in a building. So the most common types of buildings are large footprint structures. So if a building's going to have an expansion joint in it, then most of the time they have got a fair amount of concrete or large wood structure or big surface area. So things like hospitals, schools, stadiums, convention centers, airports, data centers, those kinds of things, they all have a lot of mass and a lot of space that require separation for expansion and contraction. So what you see on the bottom right is what we call a Texas wrap or Texas donut design. These are pretty common across the United States now. where they will build a parking garage and then wrap around it with commercial and residential properties. And where these are connected, there's an expansion joint gap that separates the parking garage from the rest of the structure, and that's typically fire rated. It's got structural loading, and there may be expansion joints in the individual parking garage sections themselves, and also in the units where the commercial and residential construction happened. But that just gives you an idea. These things run all throughout the structures, top to bottom and side to side. So how do these things work? Well, this is a good video that shows you what the purpose of an expansion joint is in a building, and how an expansion joint cover relates to that expansion joint gap opening. So just to lay this out for you, you're looking at a lobby area. There's an atrium that runs several levels, and you're on an upper floor here. So the bottom left, the checkered area, is one concrete slab that runs across the left part of the page and around the side of the building. And on the right-hand side, just on the other side of the blue line, there is another concrete slab. Then those two are separated by an expansion joint gap. And that gap runs across the floor, and it runs up the column there, that white column area. And so the purpose of this is to make sure that the structural load doesn't transfer laterally to a column. So columns are great at supporting weight from the top down, but they're not good at supporting loads laterally from the side. So if you had a heavy concrete slab ramming into that because of an earthquake that you're going to see in just a moment, then you could have some serious buckling. So the expansion joint gap allows the stress relief, and the expansion joint cover covers up the gap and completes the construction. So you can see the chandelier start to move. You can see the floor start to move. So those are carpet tiles, and so they've carpet tiled across the top of an expansion joint cover system. No structural damage there. It's just carpet tiles being popped up. Pretty easy to replace. This is a pretty major earthquake. You can see where the column is providing all that stress relief, and you can see all the structure moving around. So the expansion joint is doing its job. There's no buckling of the column. It's all relieved in stress. It looks pretty violent, but it would be much worse without one of those. Just as an added bonus, that curtain that you see falling down there is manufactured by one of our sister companies, and it is a smoke control system that they use these in elevators, atriums, and all different kinds of applications. So just got a bonus there. We had expansion joints and smoke curtains in the same video. So what happens underneath that floor? So underneath that floor where you saw those carpet tiles popping up, there would be an expansion joint cover system like the one you see here. Metal members maybe nested down into block out into a concrete floor. The tile could be running up beside it. In the case of that video, the actual carpet tiles were running across the top. But this is how this motion works. So during normal thermal expansion contraction, so hot and cold temperatures, maybe seasonal changes, or nighttime to daytime, or whatever the temperature change is, this thing moves around all the time, and you never really know it. You're just walking across these, and they're in different placements all over. Now, there's a centering bar mechanism in there that holds this particular type in place. It centers the plate over the joint. But when you have an earthquake, this is what's popping those carpet tiles up. It's a stress relief, and so you can see that bar. It's a spring-loaded bar that actually provides a relief, pulls that plate back down into place, and allows for all that functionality to take place. Really pretty seamless to the pedestrians that are in the structure. Minimal damage, minimal issues, and totally in functional condition post-earthquake. Not only is it applicable to earthquakes, but also high winds. You can have the same kinds of movement in buildings if you have a hurricane or tornado or straight winds or something like that. They can also cause pretty substantial movement that's pretty quick. Okay, so simple bullet points to tell you what to look for when you're dealing with expansion joints. If you're an architect or an engineer and you're putting an expansion joint in a building, and you need to know what to do to bring that all into place so that it all lines up and works. What's the application? What's the joint size and the movement? What are the load ratings? What's the environment? And what's the finish? So each one of those. Application, is it an interior floor, wall, or ceiling? Is it an exterior wall or roof, or is it a horizontal application in an exterior condition like a parking garage or a plaza or something like that? The joint size and the movement are important. How big is the gap? How much movement do you have to have to accommodate the kind of motion that you expect to see from the structural calculations for the seismic and wind and thermal? What are the load ratings? Are people walking across this? Is it going to have hospital gurneys and MRI equipment? Are you going to be driving ambulances over it? Is it a parking garage where you're going to have SUVs? Is it going to be an HS-20 load where you've got automobiles driving at higher speeds across roadway areas or something like that? You have to know those kinds of things. So all those are factors. The environment, right? These are designed for structures that are going to experience some sort of stress or load related to earthquakes, fires, and storms. And then finishes as you get to the latter part of it in the horizontal or the vertical. Are you going to have a recessed or like flush type finish, or are you going to have something that's on the surface of the floor, or are you going to have tile in the area, or carpet or concrete, or is it going to be textured walls or wall panels or different things like that? So those are the kinds of things. If you answer that group of questions, you'll be well on your way to narrowing down your choices to just a very few for any particular instance you have in a building. So now we're going to talk about the building. We're going to start with the foundation. Concrete slab on grade applications usually just have a control joint or maybe a very small expansion joint gap that would be less than an inch. Those would require very minimal sealants or small strips of elastomeric materials or something like that. They would not require anything really, really large. However, sometimes the movements are excessive because soil expansion or forces, or maybe there's large structures next to smaller structures, so they have mass differences between the structures, or you could have different types of soil. You could have a rocky soil mixed next to a sandy soil or whatever. These things create all different kinds of scenarios where you may actually have to have an expansion joint that might be, on a slab on grade application, you rarely run into something more than 1 to 4 inches, even in seismic zones, if it's a slab on grade application. So what do you choose for those kinds of applications? Well, you want to choose something that can withstand hydrostatic pressure from the floor surface coming up from the ground and from the exterior walls coming in. So what we recommend is something that's been tested to an ASTM D5385 or similar kind of hydrostatic pressure resistance. And so what we have found is that EVA foams, which are closed cell foams that may have a silicone surface or something else, or Sanaprene, thermoplastic elastomer, thermoplastic vulcanates, they work really well in these conditions because they just don't break down. They can be heat welded and seamed and spliced together, so that they're very, very good connections, so you don't have water coming through the splicing. They can be epoxied in place to the structure, so there's no water going through the epoxy, and they can withstand lots of loads applied by either the foot traffic or the wind or from the hydrostatic pressure in the structure. So those are a really good path to take you down when you're working with the foundation of a structure. So what do you do when you get to this building envelope? So we're going from the base now up to the exterior on the outside of the building. So what do you consider in that? Well, what are the kinds of environmental conditions that you've got? You've got, of course, UV, wind, hot and cold temperatures. You're going to have storms. You could have earthquakes, all those kinds of things, applying some kind of stress to your structure. So you need to make sure that you have products that are going to withstand those kinds of challenges. So on the exterior of a structure, we're going to start with the roof of the structure. So you have metal systems and you have bellows systems in there, and there's varieties of a few different kinds of things, but generally speaking, those are the two primary categories that you see. You may see some different kinds of seals and stuff in there that are extruded or whatever else, but generally speaking, you're going to have something that's going to be a built-up roof, like it's going to have a cant or a curb, like the cant on the left is a 45 degree. You're running your roofing membrane up underneath some metal frame members. You got a metal cover across the top. Or you could have a curb built up so that you've got a high profile. Maybe you're meeting the same height as a parapet, something like that on a structure where you have, these. And the metal systems most of the time they can be from 1 or 2 inch joints, but most of the time they're used in larger joints, 4, 6, 8, 10, up to 24, 36 inch joints. They can be very, very large. And then the bellows types roof can be used on flat roof applications like TPO roofing, EPDM roofing. You can also use them in silicone. So there's a bunch of different varieties of those kinds of things. But all of these have got a way to integrate the roofing membrane or the roofing metal flashing into the system so that it can all be watertight. And generally speaking, they all have some kind of a water gutter system, like an EPDM flexible seal underneath that controls water flow and condensation and things like that. What's most important on roof is that roofs are notorious for having lots of directional changes and vertically and horizontally. So you can really have a lot of challenges in there, right? You're going around mechanical penthouses and you're going around high roof and low roofs and things like that. So it's good to have choices where you've got either factory manufactured transitions that can be end caps on the edge of the structure, or they can be directional changes, 90 degrees left and right and up and down and all that sort of thing. And then allows you to have all those addressed as you build your structure out. Some systems allow themselves pretty well for field modifications to create transitions as well. But again, like on the right-hand side there, I was talking about that rubber gutter system. It's just EPDM material most of the time. It can be other materials as well, but they are draped throughout the joint opening, fastened in place. And if they're vertical, if they have a vertical leg, they will get fastened in place with a member, metal member, and reglet and flashing and things of that nature. But it keeps that water under control, and it has very, very long spans that are without splices. So these water gutters like this may run 50 feet or 100 feet without ever having to have a single splice, except for where you have directional changes. You also want to control the temperature with either air and thermal vapor barrier systems. So you want to have a system that's been tested to all the different kinds of things that you're exposed to on the exterior of a structure. And so a dry sealant application is a dry non-sealant application is really the best choice if you can do it, because then you don't have to worry about sealants that break down over time. It's sealed up and it's been tested for air, smoke, water, structural, seismic movement, UV resistance, because this system as an air and vapor barrier might not be on the exterior of the building as a finished product, but it may be on the exterior of the building for a long period of time as it's being installed and the exterior structure is not in place. So it needs to have some level of UV resistance to keep from breaking down while it's in the installation process. And then you need R values to be able to keep the cold side cold and the hot side hot and all that good stuff. And then you need to have a maximum of joint size choices, from small joints of maybe a couple of inches up to 2 or 3 feet or even bigger. And these systems can be installed in metal systems or bellows systems below them, across the roof, down the wall. They can be tied together. The roof can be tied to the wall so that you have a good transition of water flow moving out. You can put drains in these systems. They can work as smoke barriers. You can do them without insulation or with insulation. So there's lots of different varieties, different ways to go about this. But you can really control the environment of your structure with these air and vapor barrier kinds of systems. So when we look at exterior walls are not subjected to loads like people walking across them or something like that. Like you'd have a maintenance man with a tool belt or something walking across the roof that needs to be a little bit sturdier. But an exterior wall still has quite a bit of load applied to it, which could apply to either a metal or an elastomeric system on the exterior of the structure, because you have wind loads, right? And so these can create pull forces and push forces, and they can certainly create lots of movement. So you want to have systems in place that have the ability to withstand all that. But another one that's really important is it's very good, and it's a general rule of thumb, to have as few splices as possible on a structure. So you'll see a lot of what we call pre-compressed foam seals that are maybe 5 or 6 feet long. So there's a lot of splices in those applications where you may be running vertically up a high-rise structure or something like that. That introduces a lot of splices. Those splices are generally pretty good. They splice together, they butt together, they're held in place with silicone or some other kind of epoxy or something like that that holds them in place and creates a pretty good seal, but it's not nearly as good as a continuous extruded gasket. So what you see on the right-hand side, as opposed to what you see on the left-hand side, which is a pre-compressed foam seal on the right-hand side, is an elastomeric extruded silicone seal that can be bonded to the structure regardless of what kind of material that it's bonding to. It can be brick or metal, or it can be, any kind of exterior surface that you would typically run across in a structure. But these come in 100-foot rolls, so you don't have a splice for 100 feet, right? So you really minimize the ability for any chance of water to be forced in through to the structure, creating leaks and things of that nature. So these are really great for that. They move. They're very, very easy to install. They bond to the substrate beautifully, and they can be fire rated. If they're used on the interior of a structure, they can be fire rated, or the exterior, either one. If it's on a fire rated structural element of the building, you can fire rate it for 2 hours. Up to a 4-inch nominal joint that will open up 50% to a 6-inch maximum opening. So they are tremendous choices for exterior applications on a structure. They can be installed 2 different ways with a flush finish or with a recessed finish. So the top left is a flush finish, so that you can pull that out to the face of the structure. It's got a nice smooth edge. And you can just bond that with silicone on the interior face of the joint. But on the lower picture where it's on that split face brick, where you've got contours and different shape changes and things like that, like you see in the center picture, you can actually bond this in place where you have a bead of silicone down the face of the seal. It can actually match in color. On there, we have it kind of highlighted so that you can see that very, very clearly, but it's to make it the exact same color as the seal. And so it contours around all those shapes, and it fills all in those voids and things like that. And it really creates an excellent waterproof application. It can be done horizontally as well. I don't recommend any of these kinds of seals, whether they're foam seals or elastomeric seals for walking surfaces, unless they are a parking garage related type of seal. Those are okay to be walking on. But for the most part, the ones that feel like they give, I would not put those down where I would be walking, and anything larger than maybe a 2-inch gap opening or something like that. Seismic systems. So when you get to larger joints above 4 inches, when they get from 5 or 6 to 8 or 24 to 36 or whatever, even bigger expansion joint openings, the exterior of the structure will have metal or maybe large elastomeric systems to show you the kind of motions that you may incur in a building. So running up the vertical surface or running across the roof, you're going to have something that has all this functionality built into it to allow all this kind of motion. So what do these look like when you get them installed? Well, if you install in a seismic system on the exterior of the structure, they are designed to blend in with the structure. So if you're looking on the right-hand side of that building, it's a telemedicine building in San Diego. There are expansion joints on the left side, right there by where that light pole is, right beside the white area there, where you have the the big glass opening for the building. And then on the far right-hand side, on the other side of that light pole, you can see just faintly there's a couple of dark lines there, but the close-up in the center picture there is the expansion joint cover system, and you just really don't even notice it. It's completely hidden. But in an earthquake or high movement, this thing pops in and out and moves around and does all kinds of things to allow all that stress relief in the structure. And something that happens commonly in large building projects is that the architect may want to see an off the main structure mock-up. So they want to see what the panels look like on the exterior of the structure. In this case, they wanted to know what the system worked like. So we built an off-site complete mock-up with the exterior skin panels on there. They weren't the same color, but you can see this. And we stressed it and moved it like a cycle in an expansion joint application, and it opened up the structure, and it closed back, and it sealed back up. And so everybody was comfortable with how this was going to function and how it's going to look on the building. So now we move to the interior of the structure. Inside the building, you have floors, walls, and ceilings in a structure, and they all have different types of expansion joint cover systems in there. Now, in most cases, you really would like for them to blend into the structure. So if you look at that left-hand side where you see that sort of green marbly looking material right there, that white area beside that, most of what you see right there are floor, wall, and ceiling expansion joint cover systems that are hidden into and recessed into the structure, whether it's into the floor, into the wall, into the ceiling, but it allows all the same kinds of motions that you see in the other types of seismic applications. And it allows for all this motion. And in the center of the structure, you can have just an exposed metal plate like you see in the bottom center picture, an expansion joint cover plate. You can have a recessed plate that may have some elastomeric seals in gaskets in place, or it may have some kind of sealant in place so that you can place marble and tile and terrazzo and things like that inside those kinds of openings. And of course, on the right-hand side there, you can see that you have a recessed floor application with a marble wall application and a gypsum ceiling application. It's pretty seamless to people walking in and out. They really don't think much of what they're walking across right there. So it is quite nice there. So, and just for reference, that left-hand picture is the Nashville airport, the new Nashville airport expansion. Finishes, metal can be polished or painted or anodized and to look like all kinds of things, right? And so you have lots and lots and lots of choices there with metal systems there, whether they're interior of the building or exterior of the building. And so there's a lot of different kinds of options that you can do in those. My advice is that I would not put an anodized finish on a floor application where people are going to be walking because it'll wear off pretty fast. And a good indicator of that is when you're walking in and out of a building that's got a curtain wall and it's got a metal and glass door, and you look at the door handle and it's all rubbed off, you can tell people have been opening and closing it. That's what'll happen to your floor if you anodize your floor cover. So I would avoid that. But aside from that, you can do a lot with metal systems. And then systems that are elastomeric, that have elastomeric gaskets or something like that in there. If they're Santoprene, there's a few color options. You can always have custom made, but most of the manufacturers have them in 4 or 5 color options. And then if silicone has a wide range, so whether that's a silicone extruded seal, that come in 100-foot rolls, or whether that's 5-foot long pre-compressed foam seals, you have a wide range of these silicone options, and they generally follow the same pattern. They usually follow the Dow 790 pattern of colors. There are a few variations in there, but that's the most common type of application. Those are the most common kind of materials that you're going to see in elastomeric systems. You'll see EPDM mostly used as a water gutter. That's usually, or a very robust parking gasket. So inside the building, if you've got very small gaps, 1 or 2 inch gaps, it's quite common to have thermal plastic systems in place that are hybrid, that connect to metal systems. They're very good products and they hold up quite well if they're made right. The ones that are made right are the ones that are dual durometer for the most part. They have a very hardened edge that snaps into a metal frame, and then they've got an elastomeric center that allows for the stretching and moving. And the reason why you have that is because that hardened base fits into that metal frame, and when people walk across it or push carts over it or whatever else, roll their luggage bags over it or whatever, it doesn't split that seal. But if you just have only a PVC type seal, or if you have a seal that is thermoplastic but it doesn't have that extra hardened durometer to protect that seal, you'll see the seal split along the joint linear sections there, and so those kind of break down. These are available in all kinds of applications. You can put them in mud-in walls, you can put them in plaster, you can attach them to acoustical ceiling tees, you can put them in floors, and you can put them up against the walls and all kinds of things like that. A lot of variety. You can match the colors on all of them. You can change the colors on all of them. They're quite nice. This is in an airport. This is Dulles Airport and in Washington, D.C. You can see a very nice splice in the floor. This is a high traffic area. Took me a long time to take this picture to get people out of the way enough so that I could take a shot there of this, but it is very, very nice. Holds up beautifully. Very, very good seal. It's very, very, very well done. And you can miter it and put it in the flooring. You put carpet over it, tile over it, any kind of thing like that. Works pretty well with terrazzo and different things like that as well. It can be easily cut in the field with a chop saw. And so they're quite versatile. When the joints get larger than 2, 3, 4 inches, then you're going to run into metal systems of different types. And so you can have recessed systems that you can put tile and marble in, or terrazzo, like I've mentioned. You can have very heavy duty systems like the top right that I'll show you a little bit more about in a minute, that are very, very good for multiple direction movement and very high traffic loads for areas like airports, convention centers, things like that, that get a lot of abuse, a lot of traffic with bags and people pushing carts over them and all kinds of things like that. And you can have systems that are mounted to the surface of the floor in different applications. So wider joints will have a centering bar mechanism, like I showed in the little video earlier, with the system moving back and forth with the bars popping out and stuff. Gymnasium floor applications, like you see in the center there. On the right-hand side, you might have a hinge connection because you may have one side of the floor higher than the other. So a lot of different kinds of options there that you have. But this is a really good video that shows the motion back and forth. So this on the bottom right, this is also in Dulles Airport, very heavy duty system in place there that has a kind of a slot opening where the plate slides in and out of the extrusions, and it stays flat regardless of whether it is moving in and out or not. And it also allows vertical expansion and contraction. So very, very abuse resistant, super, super tough material. This thing can be in place for a long, long time. Another system that's very common is a no bump system. And this is the one I showed a little video on in the beginning there after the earthquake video. These are commonly used in data centers. They're different types, and they're called no bump systems. They're flush, and they use the different kind of robots and things in data centers to move product around, or whether they're distribution centers or whatever those are. But they're moving things around, and they want to make sure they're totally flat. And so they are really good for a completely flat application that will allow expansion and contraction, and then also a lot of relief for a seismic event. And those are generally matched with wall types covers that are very, very thin, low profile systems, like you see a snap-on wall cover there, and you can make multiple directional changes very, very easily in the field. These systems work really, really wonderfully together. And so that left-hand picture is the one I showed in a very, very small picture earlier. Now you can see it a lot better. You can see that there's a recessed floor material in the base that really works well with tile in the wood. And then, of course, the metal polished, mirror polished covers on the walls and the ceilings. And then you can see a couple of surface mounted systems on the right-hand side. One's the top one and the bottom one both can have multiple components. They can be flush with the surface of the carpet, or they can sit on top of the carpet or the wood floor and function perfectly for moving people in and out of the structure. In the interior of the structure, you want to make sure that you select elements that can be transitioned well, right? And so this is a silicone system on the left-hand side. You can make a 90-degree transition horizontal to vertical from a soffit to a wall without even having to cut the seal. You can actually bend it and fold it in. So they work really well. That's a pretty large joint. That's probably about an 8-inch wide gap there. That's in a project in Seattle. And then there's a couple of other pictures you can see where there's different kinds of applications where these kinds of elastomeric seals have been installed in navigating around or going up a wall and across the ceiling. They're also very good. Elastomeric seals are good for where partition walls meet curtain walls. So typically they'll build a curtain wall on the structure, attach it to the concrete slabs, and then they will build the wall partitions in after that. And once the wall partition comes up, it doesn't go all the way to the curtain wall, stops just short of it, leaving some kind of gap there to allow for the expansion of the curtain wall. And it's best to seal that gap. And then you can also provide sound readings and things like that. We'll take a look at those. And then you can provide, very, very nice seals inside the structure as well, up the walls, across the ceiling. So it's pretty minimally noticeable, but allows a lot of functionality and controls the environment quite well. Ceilings, again, you want to make sure you have products in place that will attach to ceiling tees, acoustical panels, or gypsum, or block, or whatever your different kinds of options are. So a couple more transition details of different kinds of systems in place there. So now we're going to move on to exterior structures like parking garages and open air like stadiums and things of that nature. We actually have full AIA training programs on parking garages. They're quite complex, and there's a lot to them because of the heavy loads and the extreme exposure to the elements. But the short version is you really got two groupings of parking garages of expansion joint cover systems. You have 4 inches or less, and you have greater than 4 inches. So for 4 inches or less, most of the time what you're going to have is an elastomeric system like you see on the top left picture there. They are bonded in place with an elastomeric concrete. There's no mechanical anchors that attach into the slab, which is great for post-tension concrete. You don't have to worry about drilling in or having to do x-rays or something like that in post-tension concrete. You can do surface-mounted applications where you have hinge applications, cover plates that are pretty robust and sturdy. But one of the things you want to make sure of is any system that you pick for a parking garage has some really good sound protection. It's got sound dampening built into it. So there's gaskets in place, or it's rubberized, or whatever it is that keeps that. And so there's a couple types of measures that are used in the industry for sound control. One is an STC rating, sound transfer class, which is an indoor noise transfer, like from one room to another. Those are important. In a parking garage application, those is a OITC, which is the outdoor indoor transfer class. And so that is where there's a lot of noise that takes place. And so if you're out there and there's a parking garage near you and you hear cars driving on, you hear that clank, 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 that's what you want to avoid. You certainly don't want that parking garage right next to your apartment building, so you hear that all the time. So we want to make sure that you've got products that you choose that are very, very quiet and work well with those kinds of environments. The other thing that's super important for parking garages is load capacity. what is going to be driving or running or moving across this open air structure. Do you have simple vehicles going slowly in a parking garage? Do you have an area where that's entering the garage from the airport that may have some higher speed traffic and it might be more exposed? Do you have areas where you may have industrial equipment like pallet jacks and forklifts, scissor lifts? All these things have got different kinds of ratings there. So you want to make sure that your system that you choose has got a rating associated with it. And you want to make sure you know what those ratings are. What is it based on? Is it based on a DEN standard? Is it based on IBC standards or AASHTO standards? Or at least, at the very least, how much load do they expect over what kind of contact area? So we publish all that so that you can see that on every kind of system that we produce, so you know exactly what it's designed and rated for when you get into it. So is it, it's good for pedestrians, gurneys, x-rays, pallet jacks, automobiles, whatever. So you make sure you make those choices to select products that are going to be applicable for your application so that you have a long life for your expansion joint system. Another key element is making sure that you have good concrete and good transitions, right? So when you have directional changes, you got to make sure that they're bonded together, heat welded together, or whatever the recommendation is from the manufacturer. And then you have sound concrete blockouts. If they are damaged, make sure that they are properly repaired and brought back to a serviceable level so that when you install the expansion joint cover system in place, the system doesn't break down because it's not properly supported from underneath. Water management is very, very important in parking garages. So we make sure that any of the gaskets or something like that that are below these gutter systems, EPDM or whatever, that they're all bonded together. There's good directional changes. You have the fewest amount of splices. You have drains, so you can drain them down columns and things of that nature, so that you have all these kinds of water control management systems in place. Now, one of the things that's great, that bottom left picture, actually, if you're doing a renovation to a parking garage, one of the best things you can possibly do, it's very inexpensive and very, very good for security and safety of your entire environment. And that is, you can run a gutter fastened to the bottom side of a concrete slab, all underneath the expansion joint covers that you're going to be renovating and tearing out from up above. You can put drains in that thing. You can run it over the columns. You can run it out to planters outside. You can do all that. You can control all of the environment that's happening there, so you're not damaging or compromising the deck below the one you're actually working on. It's a really cheap way to buy some insurance so that you don't end up with things falling on cars down below, water leaking down into everything, all kinds of stuff like that. It's a very, very inexpensive way and a very good way to go about that. So here's a good variety of the elastomeric seals that you might use in a parking garage. The top left two pictures are a floor-to-floor and a floor-to-wall version of an elastomeric seal with a elastomeric concrete that is bonded to the cement without mechanical attachments. That center left picture could be at a column location or along a wall. If you don't have the ability to do a block out, then the right-hand side picture on the top, epoxy bonded seals, they work really well. They're continuous. All these seals are, can be produced 100 feet long or even more. And then they can be bonded with epoxy or elastomeric concrete to the substrate so that you don't have water leakage and you have very minimized splices. And there's other varieties where you have snow plow traffic in the bottom left, or if you have plaza areas where you've got pavers and landscaping, or topping slab on top of a structural slab. That's the bottom right two pictures there. That bottom right picture is Hamad Medical Center in Qatar. And then when you get to larger joints above 4 inches, you're going to have metal systems, just like you do. That 4-inch rule applies in a lot of different applications. And so when you get above 4 inches, you're going to have metal systems. And so they can be recessed into the block out. So you want that as shallow as possible. So that's why it's good to have a shallow block out system, because that's the furthest distance away from the tendons. So that allows you to have anchoring without really getting into that area, at least as much as possible. You still want to always x-ray your post-tension concrete to make sure you're not interfering with any of that, or rebar at the edges or whatever. And you can do these in floor-to-floor and floor-to-wall and different kinds of applications where you might have a new to existing. So that top right picture, that connection that you see on the right-hand side that kind of has that Z-shaped piece there with an anchor going into it, kind of at an skewed angle. Those can be done where there's a wall in place, or totally where it's flat, where you're going from an existing building on the right-hand side to maybe a new structure that can have a block out on the left-hand side. You may not have a block out on the right side because you're in an existing structure and that you're having to fasten to, and so you don't have the ability to cut into block outs. Those are the kind of applications where you'd have a new to existing anchoring system. And most of the time, those are not rated for vehicular traffic, but they can be. It just depends on the type of system that you choose. And the bottom two pictures are heavy-duty systems that can allow for elastomeric concrete to be placed in the opening instead of grout. Or the bottom right is a forklift-rated no-bump version. Again, very good for industrial applications like you would have in data centers and things of that nature. There are a lot of surface-mounted options that happen in expansion joint applications for parking garages. So you want to have a hinge system, something that allows some vertical displacement while maintaining all the movement capabilities. So they can be done for large joints and small joints, vertical displacement up and down for different kind, and all with some kind of gasketing system that allows them to stay quiet. The last segment we're going to talk about is going to be fire protecting expansion joints. And so again, we have another full presentation related to fire rated joints in buildings, but we'll give you the short version on this. Fire barriers in expansion joint cover applications are very similar to what you would have in fire stop applications and other barrier management systems. You want to contain the fire where it starts so that it doesn't progress throughout the structure and it doesn't allow smoke and toxic fumes to get out either. So that no heat, no flame, no toxic fumes and gases get out of the area of origin. You maintain that, keeping that in place for as long as your barrier management system is in place. So if you have a 2-hour rated wall, 2-hour rated floor, or 3-hour rated floor, or whatever, you want to have expansion joint systems that have fire protection systems that would be in place for those same periods of duration, 2 hours, 3 hours, whatever. So when you get to building codes and expansion joints, the primary one that you run into, aside from loading that we pointed out a few minutes ago, is the fire rated section that happens in IBC section 7 addresses that. And so the IBC section 715.3 points to two test standards, ASTM E1966 and UL 2079. And those two test standards are the ones that make the rules for the time temperature curves, how much movement is required, where is the pass fail on flame and thermal and air leakage, all those, how much cycling does it have to go through before the fire is tested. So you make sure that you cover all those different kinds of scenarios. So whatever product you put in place provides a connection from one structure across the expansion joint gap to the next structure with a consistent maintained fire integrity. What's changing? Well, one thing that's changing is parking garage applications have traditionally not required expansion joint or fire stop applications to be fire rated if a parking garage is sprinklered. However, in the IBC 2024, that has changed. They are now looking at the progression of fires, like you see here with the Jacksonville parking garage fire that just happened recently, May 16th, 2025. The fires can go up or down. So heat rises and everybody knows that, but melting things go down, right? And so when you've got tires melting and you've got rubber gaskets melting and you've got other things like that, they run down through those expansion joint gaps and run down through the pipe penetrations and all the other things that you have in a structure and run down to the floors below, and they can start more fires. And so now there's progression up and down in a structure. And so that level to level fire protection has already started taking place. It started with fire stop penetrations. Joints are already in the discussion phase. EV fires, right? Electric vehicle fires, those lithium ion batteries, they are having an effect on this as well because they burn hotter. According to many discussions I've had and posts and listings from UL, Intertech, and testing laboratories, and from lots of different entities, fire marshals around the country. There's a good fire marshal discussion forum on this Jacksonville parking garage fire. They all say that these battery fires are hotter, faster, and the duration is longer, and they're not as easy to put out with traditional firefighting materials. So they are changing the rules in the parking garage and open air structure fires where you would have vehicles. So, stay tuned to that one because that's going to be developing over the next 6 to 10 years for sure. You want to have a variety of fire barriers from small joint gap openings, the up to 4-inch, which is again kind of a rule of thumb. Up to 4, there's a certain kind of things. Intumescent fire barriers are common in those size ranges. Then you move to flexible insulated blanket materials for mid-size and large-size joints. And then you want to have options if you're working in high seismic zones like you would have in California or Seattle or New Zealand, or any place, Utah, that would have these kind of large requirements, that you have barriers that would go up to even 6-foot maximum openings, right? So that you can protect any kind of structure. You want to be able to protect structure, and you want to be able to put your fire resistant system into walls and into floors and all these different kinds of combinations that they would have with different kinds of joint cover systems. So that's a wide variety of selections. When you look at the parking garage part of fire protection, because like the Texas Donut, those areas where you have a parking garage connected to a structure, the majority of the time, that's got to be a fire rated connection. So you are connecting from a parking garage to a structure, and you will be doing it from structure to structure in a parking garage, most likely in the next few years. But you want to make sure that your fire barrier doesn't interrupt your waterproofing application. So you want a fire barrier that can be installed from below the slab, or it's completely connected without having to interface with the expansion joint cover system. So like when you look here at these details, on the left-hand side, you've got an elastomeric seal that's epoxied into place, and you've got a fire barrier system that's compressible and pressed into place and applied with a construction adhesive, a spray adhesive, so that the fire barrier is completely separate from the expansion joint cover system, so there's no interference in the waterproofing. In the middle section, you've got a fire barrier that's placed from the surface into the bottom of a block out and then sealed in place with an elastomeric concrete, so that it is again separate from the cover plate system. And then on the right-hand side, you have a fire barrier that's completely installed from underneath the slab, so it's not touching the top portion of the slab or the surface mounted system or whatever you got in place. So make sure that you've got fire barrier systems of all the sizes and all the kinds of options that you need to be able to protect your expansion joint area for whatever the purpose is and the requirement for the system.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of Balco and the EBS Group, thank you for your time and attention. To receive credit for this course, you'll need to complete a 10-question quiz. Simply click the test button below to get started. A passing score of 70% or higher is required. If needed, you can retake the quiz as many times as necessary to achieve a passing score. Once you pass, your AIA Certificate of Completion will be emailed to the address you provided before taking the quiz. If you're an AIA member, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. The EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. Smoke Guard focuses on fire and smoke protection solutions. And Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on Balco, visit our website at www.balcousa.com. Thank you again for your time and interest.